Well, they're myelin sheath, right? But what kind of specific cell is it?
Schwann.
They're Schwann. And you can tell because the oligodendrites look very different. They don't have one nuclei per cell like this. They have one nuclei per cell, but the cell encases lots of different neurons. So I wish I had a picture. Let me see if there's a picture in the book. Does anybody have the lab manual? They can turn open to that book. But the oligodendrocytes is like one cell. Well, I can just explain it. You guys can look it up. It's like one cell, and it branches off and has like little wrappings around lots of different axons, okay? The Schwann cells and the PNS are just kind of like one cell, and they're just like little bulbs of myelin sheath that are encased on each axon of the PNS. So, and then here is this little bump here. What's that bump called? I just went over it.
The nucleus. Or the neurolema?
Yep, exactly, neurolema. And that's where the nucleus is and the like, little bulge of cytoplasm and everything. So what is this thing in the middle?
The axon.
That's the axon, right. So at the end of the axon, it terminates. What are those called?
Axon
Axon terminals, right. So which direction does the impulse go? Like what it's from what to what? Like
the dendrites to the axon.
So it synapses here, right? And then it sends the signal down through the axon to the axon terminals, and the axon terminals join the next cell body or the next head, and they form that what? No, the nodes of Renvier are the spaces in between the myelin sheath, which is actually not even pictured here, but that's what that is. No, it's what? It's the synaptic cleft. Remember, it doesn't actually touch. So the axon terminals of the postsynaptic neuron is going to excite and release these, the vesicles that have the neurotransmitter are going to bust open and burst, and all of that neurotransmitter is going to flow into the synaptic cleft there, and it's going to excite the next neuron. So there you have a presynaptic and a postsynaptic neuron. The postsynaptic is already sending the signal down. The presynaptic is the one that's getting excited because of all those neurotransmitters that were secreted from the axon terminals of the postsynaptic.
The other way around?
Okay. I don't think so. Go ahead.
Isn't the presynaptic releasing the neurotransmitters into the postsynaptic membrane?
Let me think about this here.
I think it's in the brain.
Yeah, but I'm confusing. I might be confusing ganglia, like the nerves, the ganglia fibers, the nerves going in and out of the ganglia, presynaptic, postsynaptic. Let me look at the book real quick, just to clarify. I don't want to say the wrong thing.
I don't know. I could be wrong.
Which one did you think? You think Janelle's right?
Yeah.
I think Janelle is right. I'm thinking about the presynaptic, preganglionic fibers and postganglionic fibers is what I'm thinking of. Presynaptic and postsynaptic, right?
I don't know where.
Janelle, you are right.
It says it?
This is the oligodendrite, by the way. That's what it looks like. So here, just really quick so I can move on. This is what a Schwann cell looks like, these individual little bulbs. And this is oligodendrite. See how there's one cell body there, one nucleus and everything, and it goes on to different axons and wraps a whole bunch of different things. So Janelle, let me clarify. It's the presynaptic fibers are what are releasing the neurotransmitter into the space. And the postsynaptic fibers, or the postsynaptic neuron, is what's receiving the neurotransmitters and being stimulated.
Okay.
Because the synapse is in the center, so presynaptic is the terminals that are adjacent to that, and then the postsynaptic is afterwards. That is correct. Let me look. I just want to make sure. Yes, that's correct. That's correct. So I misspoke the first time. So you have one neuron lined up with another neuron, right? So that and in between each of the neurons is that synaptic cleft where the axon terminals from one neuron is meeting with the cell body of the next neuron, the dendrite cell body area from the next neuron, right? So one of them is the presynaptic and one of them is the post. The presynaptic is where the axon terminals are releasing the neurotransmitter into the synaptic space, and then the postsynaptic is the next one. I'm not going to ask that on the practical. I'm just trying to explain it so I'm not explaining something wrong. Oh, so you guys just blanked. Everything that I just said went right out. Yeah, no. I'm not going to ask that. I just wanted to explain it But then I just confused everybody further, so that wasn't good. But
I think we're
Moving on.
No, we were kind of blank anyway. I was.
so yeah, Janelle was obviously the only one that was listening, but I was
That's
telling
right.
it wrong. You guys are just like, yeah, that's right, that's
We're
right.
good.
We were writing it
we all
down.
caught it, right?
You're
As long as it's not
We believe
practical.
It's not on the practical. The practical's not that hard, and it's not conceptual. The practical's a lot of identification. You've had a lot of conceptual throughout the semester. But that's the synaptic cleft, so don't get the synaptic cleft wrong. That's the only thing that you would need to know from that tirade, like that whole, like... Okay, so know the difference in the unipolar, bipolar, and multipolar neurons. That's easy, right? We know the difference between those three. Just identification, not location or what they do or where they're found. Just identification. Sensory, motor, and association neurons, just know that the neurons that are the sensory and motor are the